Electrostatics.
Now we want to see the principle of capacitor or concept of capacitor. We know that the capacitor, which is a consist of the parallel plate, right? And to the first plate we give the positive potential and second plate is earth. And again in between these two plates we keep the distance d, right? So in this way capacitor is formed. But now here the question is, inside the capacitor why two conducting plates are used, right? So the answer of that one. So here we want to see the first case. Now A case. In that, suppose here if you take the single plate, right, their area is A, right, and to this plate suppose here if you give the potential V, and due to that potential here on this plate this much amount of charges are deposited. Then for this case the value of capacitance is C, which is equal to the, what we get there, Q upon V. But what happened here, if we want to increase the number of charges, then there we want to increase the potentials also. It means that this ratio is remain same. It means that for this system capacitance which is not changes, right? But now here when we increase the number of charges we want to increase the potential, then it is dangerous for to handle this capacitor or this system, because of we cannot be handle the system of higher potential. So that's why it is very risk. So that's why we cannot be use the single plate. Then we want to see the second case. Suppose here now here we want to take the first plate is as it is, right, and again to that we want to give the positive potential, and due to this positive potential what happened, the number of charges, positive charges which is deposited on this plate, and in front of this plate we want to keep the second plate at some distance, right? Then what happened, when we keep the second plate near this conductor, and already this conductor is charged, so that's why automatically on this plate the negative charges are induced. These charges cannot be given. These charges is induced charges. It means that these charges is produced their own, right, by the induction process. Then suppose this will be the negative charge, right, but automatically again on the other side there again the positive charges which is also produced, and this positive charges called as the bound charges, right? Then what happened, due to this positive charges suppose their potential is V, due to the negative charges here potential is V1, that is minus V1, again due to this bound charges what we get there, their potential is positive V. So what we get there, so capacitance C1 which is equal to the, what we get there, charge is as it is, but what we get there, V minus V1 plus V1, automatically what we get there, plus minus get cancelled, so what we get there, Q upon V. Again in this case also capacitance cannot be increased, right? Here this negative potential increase the capacitance, but this positive potential increase the capacitance. So that's why here we want to remove these positive charges. If we remove these positive charges, then here we get only the potential V minus V1. It means that denominator which is the decreases, automatically this ratio is increases, right? So that's why here we take the two plates. Suppose here this will be the first plate, and again to the first plate here we give the positive potential. Due to that here the number of positive charges are deposited. Suppose here positive charge is Q, and in front of that we kept the second plate, right? Here the negative charges which is induced, here this will be the negative charge, and all these unbound charges which is removed by, if we take the earth. It means that if we give the earthing to the other side of the second plate, then at that time all the positive charges which is moves inside the earth, right? So it means that in this system, now again here we get only the positive charges on the first plate and negative charges on the second plate. Then what we get there? The potential of first one is there V, and potential due to the negative charges are there minus V1. Then what you get there? The value of capacitance C2 which is equal to the charge upon V minus V1. It means that if we compare the C which is equal to the Q upon V, again here we get the same value, right? But in this case what happened? The Q upon V minus V1. It means that in this case the value of denominator which is a decreases. So that's why this ratio is increases. So if we compare here the value of C1 which is equal to the C, but what happened here? C2 is greater than C1. It means that capacitance of this system is greater. So that's why for capacitor we take the two conducting plates. To the first plate we give the positive potential and second plate is earth, right? This is about the concept or the principle of the capacitor. And again this capacitor, the symbol of this capacitor is simply, here we want to give the two parallel plates, right? Again we get the another symbols also, but that symbol is the that is the symbol of battery. Here there is the difference between the symbol of battery and capacitor. In capacitor these two plates are, that is their lengths are same, their cross sectional areas are same, but in this case what happened? Here positive plates represent the larger plate and negative plate represent the smaller plate, right? So this will be the difference between the, so this will be the capacitor and now this will be the battery, right? So here this will be the symbol of capacitor, right?